Okay, so this is number 11 on your checklist, which is called choosing a graph to fit a narrative. So essentially what we're doing here is we're taking like story problems, a verbal description of something going on, and we're matching it to a graph that models the verbal description. Okay. From my experience with this topic, a lot of kids get frustrated with it because they're not paying attention to what are on the axes of the graph. Like, they're not paying attention to this and that. Okay. If you read the graphs and read carefully, most of them are pretty decent, but if you're just going to skip ahead, it's going to get frustrating. Okay, so we'll see the ones that kids commonly miss. All right. So you should have these notes out in front of you. Obviously, taking the notes that I give you. You should be doing this in pencil. I'm writing in pen just because it shows up better on the video. Okay. So, and by the way, these are all going to be like multiple choice questions. You're not going to actually have to draw a graph the way it is in the assignment. Okay. So for number one, Lucy rides down an escalator toward the ground floor. Okay. So we have time on the x-axis, the horizontal axis, and we have Lucy's distance above the ground on the vertical axis, the y-axis. Okay, so she's riding down an escalator toward the ground floor. So she's riding down toward the ground floor. That means she has to be above the ground floor. So she's going to start at a height that's somewhere above where she's going to wind up. So this graph over here, she starts at a high point, and she goes on the escalator, keep going down and down and down until she gets to the ground floor. All right. So your answer to the first one is going to be that graph. Okay. Okay. Greg drives at a constant speed for a while. Okay. Constant speed means obviously his speed is going to be the same. So he's going 30 miles an hour, for example, the entire time that he's driving. So what's going on in this graph? Well, the speed is certainly not constant. Here he's going, let's say, 45 and then slows down to like 40, 35, 30, 25, etc. I know we don't have numbers, but that's, if you follow along the line, that's would make sense. Okay. What's happening here? Well, let's say he's starting at like 25, 30, 35, 40, 45, 50. Okay, so that's certainly not constant. What's going on with this weird graph? Well, he's not really doing much at all. Let's say this is, for time, let's say this is 3 minutes. Okay, what's his speed over here? Well, we don't know. We don't really have enough to answer that because it's not connected to the rest of the graph. Okay, so this one is out. This one is junk. All right, what's going on over here? Well, let's say his speed is 30. If it's 30 here, 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 it's going to be constant throughout, which is what the question is looking for. Okay. All right. Number two, Goran walks at a constant speed to the store. Okay. Well, speed, time. Okay. You want this to be constant. So is the speed constant here? No, the speed is decreasing. It's going down. It might be 40 here, going all the way down to like 20 over here. All right. Speed here, And here, the line is increasing, it's going up. So the speed might be 20 miles an hour over here and might be going up to 25, 30, 35, 40, 45, etc. Okay. This is one of these weird graphs, has nothing to do with anything in the situation, and this is your constant graph. Okay? All right. Lucy drives from work to home. Okay? So this is one you have to perhaps think a little more about. Okay. So we have time and Lucy's distance to home. So she's driving from work to home. So she's at work and she's leaving to go home at the end of the day, all right? So if she's driving from home to work, should she be getting closer or further away to her home as she drives more? Well, unless she's taken the wrong way, she's getting closer to home, all right? So her distance to home should be going what? Up or down? Down, because, she might work 10 miles from home, and then after a minute, she's 9 miles away. After 2 minutes, 8 miles. After 5 minutes, 5 miles. After 9 minutes, 1 mile away, and then finally she's home after 10 minutes, okay? So we're looking for a graph that's going to be decreasing going down, which is going to be this one over here, okay? What does this graph mean over here? Well, her distance to home is increasing, so she's leaving work, and then the more she drives, she's further away from her home, which obviously is not what she wants, which means she's lost over here, okay? This, one of these weird graphs, ignore them. They have nothing to do with any possible scenario here, all right? What's happening over here? Well, she leaves, all right? She's 10 miles from home after 0 minutes, 10 miles from home after 1 minute, after 2 minutes, after 3 minutes, after 4 minutes, after 5 minutes, etc. Okay? So she's driving, and she's not getting any closer to home. So what's she doing here? Maybe she's sitting in a traffic jam, maybe she's sitting at the drive-thru, whatever. But the bottom line here is this graph is telling us that she's not going anywhere, she's not getting any closer to home, okay? So again, you have to read carefully over here, okay? This graph does not mean that her speed is constant, okay? Because this has nothing to do with speed, okay? This has to do with distance. Her distance is constant, which means she's not getting any closer to home, which means maybe she's sitting in a parking lot somewhere, okay? All right, so we're going to go to the back side of the notes. All right, number 3. So for each scenario below, choose the graph that gives the best representation. So Ivan stands on a high dive platform for several seconds. So he's getting ready to dive into the pool, and then he dives into the pool and swims around. He then climbs back up toward the high dive platform. Okay, so on the x-axis here we have time, on the y-axis here we have the distance above the pool. Okay, so this first sentence over here, and these are going to be a little more complex. So he's standing on a high dive platform for several seconds. While he's standing there, what's happening to his distance above the pool? Is it going up, increasing, is it decreasing, or is it doing something else? Well, you climb up to the diving platform, and then you're standing there, so you're not moving at that point. So we're looking for something that's going to be constant. So which graph starts off as constant? Well, this one does, this one does, this one does, and this one does, okay? So sometimes you want to kind of use process of elimination, and if we didn't see the first one starting off with a constant, then we'd be able to eliminate one of the choices. Okay, so that's this first sentence. Then he dives into the pool and swims around. Okay, so when he dives into the pool, is his